Hi everyone, so let's look at a more complex version of the last example where we don't want to create a hole but more like a path that cracks open because it's more interesting. So we have of course a box here and let's Voronoi that one and we use a scatter. And to make it a bit more interesting, let's scatter inside. So I use an ISO offset to turn our box into a volume. Let's increase the resolution and make sure maybe that the scatter is not relaxed. So turn relaxed iterations off so it's a bit more chaotic. And the whole thing looks like this now. And we can visualize the pieces by clicking on this button and there we have it. So let's finish the setup first. So of course we need a bullet solver and let's deactivate the points. Or actually let's first see what happens. If I run this, the whole thing should fall down. So that looks good. Then we assemble the whole thing because it's easier to work with packed versions of this. So let's make sure we pack the whole thing and make sure we don't override the name attribute because it already comes from the Voronoi fracture. It's not super necessary here, but it's a good habit to have. And then let's use a point wrangle that we call active0 to deactivate all the pieces. So we set the active attribute to 0. And if we run this again, nothing should happen. Looks good. So how do we activate this now? I think the best way is to draw the curve that we want to follow. So let's use a draw curve. And this time I think we just use the original box as an input because we can now go to projection and change it to geometry. And now we can just draw our path here. So let's draw something, maybe something like this. Why not? And maybe we resample the whole thing because what comes out of a draw curve is always pretty ugly. So with a resample, we can make it a little bit nicer, something like this. And now we can't use a group or anything, but what we want is we want to influence the attributes on the box by something from the curve. And the best way to do this is actually to use the attribute transfer, because this way we can transfer any attribute from one to the other based on the distance. So let's use attribute transfer. And what we want to transfer or change is the active attribute. So let's create the attribute on the curve and let's set it to 1. And let's call this active 1. So let's clear later what this is doing. And the attribute transfer should only transfer that attribute active. Now, if I run this, everything all of a sudden becomes active. And the reason, of course, is that the attribute transfer, as we've learned before, has a horrible default under conditions of a distance threshold of 10. So maybe let's lower this to 1 and we should see better what's actually happening. And here you can see, okay, so in a distance of 1 meter, the curve gives its active attribute to the box. And this is why only in this area all of a sudden the pieces are active and fall down. And if I turn on real time, it looks a bit more natural. There you go. This is not what we want actually, because we want it to grow, but this is the base of our setup of just transferring attributes from the curve to the geometry. So how can we make this growing? Well, there are different ways of doing this, and the easiest is probably using a node that we haven't seen so far, and that is the carve node. Now what you can see here is that a curve always has a U, and we can actually use the first or the second U, so basically from the beginning or the end, to animate a growing effect, which is a really cool thing and exactly what we need here. So all we need to do really is to animate this from 0 to 1, the second U, so that it starts from the beginning, by pressing Alt on the attribute on the first frame, and then let's say until 48, which is 2 seconds, the whole thing should be grown to the full length, and then that looks like this. And since it's growing, it will still have the active attribute on it, but over time transfer its attribute from the curve to the geometry. And this will then look like this, which is exactly what we want. Of course, it might be a bit too fast here, but you can see this way you can animate the breakup the way you want. We can actually visualize the whole thing, by the way, by just pressing the I, and then we should be able to see the active attribute. Now, the problem with that is, as you can see, we can't see any information, and that is because, unfortunately, Houdini still has the problem of not being able to properly show attributes on packed primitives or packed geometry in general, which is really annoying. The best way of doing this is to just unpack it purely for visualizing the attributes and making sure that you transfer all the attributes from the packed version to the non-packed version, and then you can actually use the visualization that we created here, and you can actually now see it in the viewport. And you can also, of course, change the visualization from color to, let's say, marker, so that we can actually see the numbers and they turn from 0 to 1. If you want to double check what your attributes are actually doing, which is always a good idea. Let's switch to color and ramped attribute, and then you can see it again in form of colors. Okay, so this is our cracked ground example. I hope this is helpful. Thanks very much and see you later. Cheers.